chapter 15 is going to be our chapter on heat. Okay, so we have a formula, Q equals to mc delta T. That is going to be the heat that's required to change the temperature of something if you know the specific heat. Okay? There is going to be another problem that is going to be a mixing problem of the two objects in a calorimeter. And if you remember, we did MC1 like this times the T minus T final. This has to equal to the mass 2 times the specific heat 2 times the T final minus its T 2 like that. Okay, and so your job is going to be asked to find this this final mixing temperature right here. This is T1. Okay, so you should be able to, with the information given, the mass and the specific heat of item 1, and this is the hot side, it's going to go down like this, and the cold side is going to be like this. You should be able to set them equal to it and get it equal to what it is. Yeah?
I realize what I got wrong on that question now.
Yeah.
Me too.
Okay. On another problem on in this chapter, and we did it on the quiz or the test, and this has to do with you have to know how to do the 5 phases like this. You know, it's going to go up like the 5 heat zones, right? A block of ice is going to move up like this. Okay? So you remember, in these zones here, you have to do mc delta T for the particular substance, ice, water, and steam. In these little zones that are here and here, these are called latent heat zones. The heat is just here, the mass times the latent heat of fusion, and here it's the mass times the latent heat of vaporization. So you will have 5 zones to do. One here, then that one, then across the 100-degree change there, then there, and then there. And you add them all up and you should get the total heat required to melt something that goes all the way from one end to the thing to the other. Okay, are we good with that? So far, so good?
Hold on.
This is just a repeat of the one we just had. You should be able to do very good on it.
Okay.
Okay, and the final question in this section is, it has to do with the ratio of the thermal energies with the radiant heat transfer. So you have radiant heat. So remember, we have Q equals to S times T raised to the 4th power. So if you're going to get a ratio of Q1 to Q2, then you have T1 to T2 like this. So remember, it's to the 4th power. So this cancels out. So remember, the ratio of the heats is whatever T1 to T2 is raised to the 4th power. And know that these have to be in Kelvin. Kelvin. Okay? So real simple problem there. Okay? Are we good? So far, so good? Yeah. Okay, so now we only have 5 problems.